Before we start, I'll talk about our operation. And I'll show you some pictures. And this is Taipei, and Beijing, and London, and this is Tokyo, and
New York.
New York. Yeah. And what are their common features? Yeah. They are all skyscrapers. Yeah. And this city has a lot of tall buildings, and the more prosperous, the taller. Yeah. And it causes an expensive space. And, about 20 years ago, you may use this money to buy a large house, but nowadays, you can only afford a small room. And what if you someday you want to play a piano at home, and you will find that there's no space to put it. Yeah. Okay. So we want to use the Virtuano, yeah, which is smaller and lighter. Yeah. What are its features? First, as I just mentioned, it's light and small. It's lighter and smaller not only than the piano, but also than the pianic. Yeah, because it's just formed by pieces of paper. And the next, it has 5 instruments, 5 sounds. It's piano, drums, flute, and cello, and violin. And you may say a common electrical piano has not only 5 sounds, but our Virtuano is more convenient because it's lighter. And next, it can be a recorder. And this recorder is not to record like speeches. It can combine music together. And as you record repetitively, and it becomes a mixer. Yeah. And what can we do with this function? If you want to practice a musical duet or trio, and your partner is not here, and you can repeatedly record it, and you can form it. For example, you can play a piano and use it as an accompaniment, and you can record a flute next, and then you can form a piano flute duet. And more times later, and maybe you can form a one-person orchestra. Yeah, so that's why we produce this Virtuano. And then next, we'll introduce the techniques for it.
Now, I'm here to introduce our techniques. Okay. First, we want to talk about keyword recognition. We try several ways to recognize our keywords. And first, I'm going to talk about our first method. We try to choose 4 lines crossing the keyword edges. And we choose the points crossing these edges here, shown as the yellow points. And we use the point pairs to form the keyword edges, just like the pink and green lines here. And the formula we use is like this. It is a linear equation, but it takes huge amount of multiplication and division, and it is too complicated for the board to calculate, and the clock cannot handle it. So this method is sort of a failure, yes. So we choose a different method. Here is the original keyword, and we use a special keyboard with red and green lines to form the keyword edges, shown here. Okay, so the red line is the edge of the black and white keyboard, and the green line is the edge of the white and white keyboards. And as the VGA scans horizontally from top to bottom, it takes the first line that crosses 30 red lines and 7 green lines as the top boundary. And as it scans to the middle area, it takes the 30 red lines and 20 green lines as the middle boundary. And to the bottom, it takes crossing less than 22 green lines as the bottom boundary. So with these three boundaries and the red and green lines, we form the keyboard. And you may ask why we have interleaving red and green lines in the middle area, like here, because as the camera scans, due to the characteristics of the lens, it may become deformed. So we have to use these intervening lines to make sure we do have a middle boundary crossing 30 red lines and 22 green lines. And here is the picture that we recognize the keyboard. And the different color represent different keynotes. Okay, next we are going to talk about fingertip detection. The first step is to make sure that we separate the hand from the whole environment. And after we did some paper survey, we took some range that in the RGB color space. And the definition of the skin color definition we take is R greater than 95, G greater than 40, B greater than 20, and R minus G greater than 15, R minus B greater than 15. This is our skin color detection. Okay, so we have a hand, the shape of a hand here, like this, color as red. And step 2, we scan from top to bottom. And for each pixel line, if the width of the skin color is in a certain range, say about 20 to 50 pixels here, then we choose the midpoint of this range as the fingertip. But if we do so, then the fingertips will be detected as like this. And the whole finger will be detected as fingertips. So we have an extra limitation to this. So step 3 is to record the x-axis of these middle midpoints. And we record only the topmost fingertip and record the x coordinate. Sorry. And if the subsequent pixel lines detects the midpoint near the topmost fingertip, then it will not be detected as a fingertip. It will be skipped. So after this process, only the topmost fingertip will be detected. It will be shown like this as the white dots here. So this is our fingertip detection. Okay, next I'm going to talk about audio processing. And we store an octave of each instrumental music in flash memory. Only one octave. And what about if we want to produce higher or lower pitches? We use some audio signal processing techniques to do so. We do some upsampling and downsampling to extend our pitches or fundamental notes. Here is the original signal. It's an example. And if we want to produce higher pitches, we downsample the signals, shown here as the blue samples here. And because the playing bit rate of the music is fixed, so we can downsample and make the signal becomes like frequency twice as the original one. So this is the higher pitch of the octave. And if we want to produce lower pitches, then we upsample the original signal like this. And for here, we use zero-order interpolation to produce the extra samples. So if we want to produce higher or lower pitches from the keyboard, because we store only an octave here on the keyboard, then we have to use upsampling and downsampling to produce extra pitches. And last, we record a sound through microphone, and from flash directly or from SD-RAM. Here we have a signal from a microphone, and we have the musical notes from flash, and we combine them together. We buffer them in SSRAM, and after we finish recording it, we store them into SD-RAM. And the signal in the SD-RAM can be extra added to the signals from flash and the microphone. So we can mix the music again and again and again. This is our method. we buffer them all in SSRAM and store them in SD-RAM. And the music we play to the speaker devices. This is our parsing techniques. And here's our modular structures, our hardware block diagrams. And we use two D270 boards here. And then one board, we use all the memory to store all the music, SSRAM buffer, and the SD-RAM store, and flash music. And the other D2 board we use to save our keyboards. Yes. And for details, the poster here also has a block diagram here. And this is our data flow diagrams. We first detect our keyboard, and then we save our keyboard to the SSRAM memory. And then we have to do fingertip detection, and we use the two results to find our corresponding keyboards. That means that we use our fingertip and see which node it lands on. And we have the corresponding node, and we read the music from flash, and we have the cycle here just mentioned before. And it's also on the poster, so for details you can also check the posters here. And we talk about our future work. The first one is to improve our stability and reliability of the fingertip detection. Because it can be influenced by the environment and it's pretty unstable. So we have to fix our light sources, and we can better improve it. And the second one is to find an easier way to recognize the keyboard. That means that we want to find a method that doesn't use a special keyboard, and it records a keyboard directly. And the third one is to reduce the memory use of each music. Because we now store an octave of music in flash, we want to store only one key note and use some signal processing techniques to generate different pitches. Just use one pitch of key notes to generate all pitches of music. Yes. And this is all our presentation. Thank you for listening to our presentation. We hope you like our channel. And if you have questions, please feel free to ask us. Thank you.